Hello learners, welcome to this session. The title of the session is Introduction to Embedded System. This is the part of Certificate in Information Technology course CIT-02 Block-4 Unit-1. I am Professor Subrahmanyam, Director, School of Computer and Information Sciences, Indira Gandhi National Open University. So, before going ahead, let us learn the definition of the embedded system. An embedded system is a combination of computer hardware and software and perhaps additional mechanical or other parts designed to perform a specific function. So, here in this particular system, it consists of the hardware part like the chip that we are talking about, the IC that we are talking about, and the embedded software like the firmware. We call it as the firmware, the programs that are being written into any ROM, those are also called as firmware, or else in any integrated chip which will be permanently staying in the chip. Those particular programs are called as the firmware. So the embedded system is nothing but it is a combination of the hardware, that is a chip, and the programs residing in that particular chip, and those are permanent of nature. So apart from this, it perhaps may contain additional mechanical or other parts also. So this individually is not a computer or not the full-fledged system. So it is having a limited functionality, and this is designed keeping in mind a specific function. So this is the definition that we can give for the embedded system. So taking the examples, the microwave oven that we are using will be having this embedded system inbuilt. Almost every household has one, and tens of millions of them are used every day. Frequently an embedded system is a component within some larger system, that is what I am talking about. So this itself is not a system we can consider, but this itself is a like a processor or else a microcontroller, you can say, which will be catering to a special function. So you can define the embedded system in many ways. So in many textbooks you have several definitions, but ultimately the underlying thing is that it is a chip and the programs residing in the chip. An embedded system can be thought of a computer hardware system having software embedded in it. That is one of the definition taken from one textbook. An embedded system can be an independent system or it can be a part of a large system. An embedded system is a microcontroller or microprocessor based system which is designed to perform a specific function. So in this way we can define the embedded system. So nowadays the cars that we are using comes with the embedded chips. Not only one particular system, but it may be having several systems which will be looking after individual specific function. So the intelligent washing machines that we are using, that also comes with the inbuilt embedded systems, or else the remote control that we are using for the intelligent TVs. So those also contains the embedded systems built inside. So I had given many examples here pertaining to the embedded systems, like the anti-lock brakes, autofocus camera, Canon, then other Sony and other kinds of cameras nowadays are coming with the embedded systems, inbuilt embedded systems. Maybe for image processing, maybe for storage, maybe for other reason. So automatic teller machines also contains the embedded system. MPEG decoders, you can see there is a long listing, camcorders, pagers, then industrial equipment, teleconferencing televisions, then set-top box. So the TV set-top box also comes under, will be having these embedded systems, washers, dryers, disk drives, printers, satellite phones, mobile phones, scanners, whatnot. There are several systems but most of the people we are unknowingly using these embedded systems. You can see their long list going on your slide. So these are all these kinds of devices comes with the embedded system. So you can see on this slide the player, Sony player is there, then Blu-ray player is there, cars are there, and then Google glasses are there. So there are even thermostat, automatic thermostat is there. So there are several examples that we can quote for this inbuilt embedded systems. So coming to the characteristics part, one thing is it is mainly single function. In most of the systems that we had seen in the list, the embedded system is inbuilt with single function. Suppose if there are 3 functions to be catered to, so 3 different kinds of embedded systems may be possible to insert into the system depending upon the functionality. So an embedded system usually performs a specialized operation and does the same repeatedly. For example, a pager always functions as a pager. So the inbuilt embedded program that is there in the pager, it is nothing but it displays some characteristics after the communication is done to that particular pager. The other characteristic that we can talk about is that tightly constrained. All computing systems have constraints on design metrics, but those on an embedded system can be especially tight. So there won't be any kind of leniency or else any kind of loosely constraints placed in the embedded systems. So if it is meant for, means that will be working as a specific task and it is tightly constrained. So design metrics is a measure of implementation features such as its cost, size, power and performance. So all these 4 metrics we can consider them as the design metrics, and it must be of a size to fit into a single chip, must perform fast enough to process data in real time and consume minimum power to extend battery life. So most of the systems that we are talking about runs on a battery. So the power consumption is a metric that we have to consider while designing the embedded system. And whenever we select the simple chip, IC, integrated circuit chip that we are talking about, and in order to program that particular chip, we have to see whether that particular chip fits inside the equipment or not. That also is the main metric that we have to consider. And then the processing power, that also we have to see whether we have to use only 8-bit or 16-bit or 32-bit, whatever the case may be. So the processing power, the capacity, and then the real-time response, that also one needs to see under the metric. Then let us learn the third characteristics, that is the reactive and real-time. Many embedded systems must continually react to the changes in the system's environment and must compute certain results in a real time without any delay. Part of it we had already studied in the earlier characteristic, but you can see here it has to respond immediately to the system's environment. So the response, the program's response should be immediate. Then only it caters to the need of the particular equipment. Example, you can see here, consider an example of a car cruise controller. It continually monitors and reacts to the speed and brake sensors. So it is functioning as a single, to monitor the speed and the brake sensors. So a particular embedded system is been placed in order to monitor the speed and the braking sensors, and it must compute acceleration or deacceleration repeatedly within a limited time. A delayed computation can result in failure to the control of the car. So this chip is a sophisticated, and one more thing is it is acting on a real time basis. So once there is a thing that needs to be monitored, then immediately whatever the response that it should make, immediately it should take, and depending upon the responses, automatically the meant for the activity will trigger. So that is the third characteristic that we have to see. And then all these things are either microprocessor based or else microcontroller based. Let us see the difference of microprocessor and microcontroller in the later on side. So it should be basing upon either a microprocessor or else a microcontroller. Then it will be having a memory. it must have a memory. As its software usually embeds in ROM, it does not need any secondary memories in the computer. So I told you it consists of the read-only memory kind of thing. The chip is read-only kind of memory, wherein which the contents that are embedded in the software embedded in that particular ROM won't allow you to change that particular program. Then connected, it must be connected peripherals to connect input and output devices. Then there should be some some parameters coming inside, and those parameters will be monitored depending upon the program that is being fed into that particular embedded system. Then it should reflect to those particular parameters. Hardware and software systems. So software is used for more features and flexibility. Hardware is used for performance and the security. So let us see where we can use this particular embedded system, that is the purpose of an embedded system. Each embedded system is designed to serve the purpose of any one or a combination of the following tasks. One may be data collection, or else storage part, or else some sort of representation, and then it may be used for data communication, data processing, monitoring mechanisms, controlling mechanisms. Suppose if you use these particular embedded systems in industrial production control or production control system machines, then these particular things will be controlling the parameters and other kinds of things. Even in power companies also they will use, power institutes also they will use these kinds of controlling embedded chips, so that whenever there is a kind of abnormal thing happening, immediately it triggers to the security kind of thing, or else some sort of factors wherein which it can lower down or upper increase the things in the industrial control. So application specific user interface also can be provided using these embedded systems. So let us see here, there are various components we can talk about whenever we consider an embedded system. So here the main thing, that is the sensors that are needed, and then the memory that we are talking about, and then the processor, either it may be a microprocessor or else it may be a microcontroller. Then a hardwired unit is there. It consists of the application specific logic, the timers, the analog to digital or digital to analog converters you can say, and then the actuators, that is the triggers, and then the output kind of thing. So these are all things, the input parameters will be sensed by the sensors, and then the memory is there, processor, and then the actuator. So these are the four essential components that any embedded system will be having. Here you can see the user is sending the input parameters, and then this particular thing we can call it as an embedded system environment. So the whole thing that is placed inside the OL, we can call it as the embedded system environment. So let us see one by one the component which is the part of the embedded system. First one is the sensor. It is the main essential part where it will be sensing the parameters. So it measures the physical quantity and converts it into an electrical signal which can be read by the observer or by an electronic instrument like the analog to digital converter. So this sensor, whatever the signals that it receives, the physical quantity signals, and it converts those particular things into the electrical signals, and later on there is a converter, you can see in the diagram, that is the analog to the digital. So it does, that particular converter does whatever the electrical signal that is in the form of analog, that will be converted into a digital form. So a sensor stores the measured quantity to the memory. You can see another component that we are talking about is the memory, and sensor is continuously storing these measurements quantity to the memory. Next thing is the analog to digital converter. So an analog to digital converter converts the analog signal sent by the sensor into the digital format. Then comes the part of the processor and ASIC. So processors process the data to measure the output and stores it into the memory. So whenever the storage part is coming into picture, then the little bit of memory, whatever that is there, that plays the major role. Then there is another converter that is called as the digital to analog converter. So a digital to analog converter, or else you can call that one as the D2A converter, converts the digital data fed by the processor to its equivalent analog data. So then the last component we will be talking about is the actuators. So the actuator compares the output given by the D to A converter to the actual expected output that is stored in it and stores the approved output. So here it is a kind of thing wherein which the check-in mechanism comes into picture. So an actuator is comparing the output given by the D to A converter and whatever that is, and it is checking against the parameter or else the result that is stored inside the chip, and then it is doing accordingly, whether it is whether it is within the limits or beyond the limits. So those particular things, depending upon the the output, it activates. So let us talk about the processor part. So the processor is nothing but it is the heart of any embedded system. Not only embedded system, but suppose if we talk about any like a computer, laptop, or whatever the case may be, the heart of that particular computing device is the processor part. It is the basic unit that takes inputs and produces an output after processing the data. For an embedded system designer, it is necessary to have the knowledge of both the microprocessor as well as the microcontrollers. So microprocessor has two essential units, as you all know. One is the control unit and other is the execution unit. So control unit includes a fetch unit for fetching the instructions from the memory one by one, and then the execution unit has circuits that implement the instruction pertaining to the data transfer operation and data conversion from one form to the other form. So the execution unit includes the ALU part also. Suppose if it consists of some logical or arithmetic operations to be done, then this particular execution unit consists of the ALU unit, and it takes care of that arithmetic and logic calculations and the necessary things. So a processor runs the cycles of fetch and executes the instructions in the same sequence as they are fetched from the memory. So you can see the diagram, block diagram of an embedded system written over here, and it is not showing the complete like whatever we had talked about, all the components. So this particular diagram we can call it as a embedded system block diagram. So the whole system is being shown as a block, and inside that particular block or else the inside that particular oval, whatever you had seen in the earlier slides, so that is being shown as a green and yellow color block, and that yellow color block consists of the embedded system, that is nothing but the chip and the programs written on that particular chip. And then you can see the input variables are interacting with the system, and depending upon the input variables, the measurements of the input variables, the output variables are being thrown out or else monitored and are being executed. So you can see one part is the interface part and the other part is linking to the other systems. As we are talking about most of the embedded systems, they are part of the larger system. So when they are part of the larger system, so this particular embedded system may be connected to the other systems also. So this particular diagram on your monitor is nothing but it is called as the block diagram of the embedded system. So the embedded system hardware includes elements like the user interface, as we had seen, the input output interfaces, display and memory. Generally an embedded system comprises power supply. Then what this particular point is nothing but it talks about the inside part, that is the block that we are talking about, the embedded system block that we are talking about. So it comprises of the power unit, the processor, the memory, the timers, the serial communication ports, system applications, system circuits or else external interface device. So these particular things comprises of that particular block of embedded system. So there are like three processors that we can talk about. One is the general purpose processor, single purpose processor, and then application specific processor. So general purpose processor is nothing but it is a programmable device used in a variety of applications. So we can see we were using these particular general purpose processors in the systems also. So this is also called as a microprocessor, whatever the computers, laptops, tabs. So every device, the computing device will be having this microprocessor. And then the features are nothing but it is program memory and general data path with large register files and general ALU. So all these things are there in the as the part of the general purpose processor. Then coming to the features, it is low time to market and NRE cost and high flexibility. So let us take an example. There are several things that we can quote: Intel processors, Pentium processors, or there are several processors which are very much general in nature. So these particular general processors, general purpose processors, we use it in the computers, laptops, tabs, etc. Then comes the single purpose processor. So the name itself is saying that it is meant for single use or else single purpose. So digital circuit designed to execute exactly one program. So only one program it can execute, and also as a co-processor. This is also known as a processor. It is just co-processor, and this is just the subordinate of the processor, or else you can call it as an accelerator or a peripheral. So the features are nothing but it contains only the components needed to execute a single program, and then no program memory is available, and it is very fast because this is a simple device and it is meant for doing only one particular task or function. So it is very simple, fast, low power consumption and small in size. And then coming to the third kind of processor, that is the application specific processor. So programmable processor optimized for a particular class of applications having common characteristics. So this is not considering the complete program, it is considering only the application, specific application. So either controlling of the brakes, controlling of the speed in a car. So particular specific application it will be dealing into. So it compromises between general purpose and single purpose processors, and features being the program memory, optimized data path, and the special functional units. These are the features of this specific processor. And then benefits are some sort of limited flexibility, good performance, small in size and lower power consumption. So these are the benefits of this application specific processor. Here also you can observe the name itself is saying that it is only meant for single function or a single task, that is single application only. So there are several types of embedded systems we can talk about. Some are standalone, some are real time, some are network based, some are mobile and embedded systems, mobile embedded systems. So coming to the standalone embedded systems, these standalone embedded systems do not require a host system like a computer, and it works by itself. For example, MP3 player you take, it works by itself. There is nothing to be connected to a main computer and needs to use that MP3 player, like the digital camera, video game consoles, microwave ovens and temperature measurement instruments. So all these particular categories of examples comes under the standalone embedded system. It takes the input from the input ports, either analog or digital, and processes it, calculates and converts the data and gives the resulting data through the connected device, which either controls, drives or displays the connected devices. So these are the three functions it will does. Either it will control, suppose if the programs are meant for controlling, it will control. Otherwise some sort of triggering it should do, then it drives some sort of a thing to happen, and then suppose it is meant for controlling, driving, and then some needs some sort of a display kind of mechanism, then also it will display to the connected devices. The second kind of embedded system that we can talk about is the real-time embedded system. A real-time embedded system is defined as a system which can give a required output in a particular time. So this is a real-time response that we are talking about. These types of embedded systems follow the time deadlines for completion of a task. Suppose if something, the response is not as per that, like immediate, in the form of immediate, then there may be a haphazard may happen. So real-time embedded systems are classified into two. One is the soft real-time systems, and the second thing is the hard real-time systems. So the third category is the network embedded systems. So these types of embedded systems are related to a network to access the resources. The connection network can be a LAN, WAN or the internet. The connection can be any wired or wireless. So whenever we talk about this network embedded system, the thing that strikes immediately, the example that we strikes is the wireless router. So that will come under the network. So that particular router will consist of a network embedded system. This type of embedded system is the fastest growing area in embedded system applications. So maybe these particular things are being used in the Internet of Things or Internet of Everything also. So these are nowadays the major like fast growing area is the network embedded systems. The embedded web server is a type of system wherein all the embedded devices are connected to a web server and accessed and controlled by a web browser. So example we can quote here is LAN network embedded system. A home security system also can be the second thing, wherein all sensors are connected and run on the protocol called as the TCP/IP. Then the fourth category we can talk about is the mobile embedded system. So the mobile embedded systems are used in portable embedded devices like cell phones, mobiles, digital cameras, MP3 players and PDAs. The basic limitation of these devices is the other resources and limitation of the memory. So you can see there are one or two examples that I want to show. A car is integrated with control, communication and information system. So here one chip, one embedded system is taking care of the gearbox controls. The other information is taking care of the information. The third embedded system you can talk about the climate control, and depending upon the climate inside the car, the AC air conditioning may on, may set to certain limits or may off. So for that reason also we can use a simple embedded system in the motor car, and then a motor control may be placed and ABS braking systems. So all these things, just for example, here we had shown some 3 to 5 embedded systems that are inbuilt into a car. And then this other example we can quote is a simple electronic system or consumer electronic systems like the digital camera, home electronics, or else the washing machines that we use, or else the security like devices, security locking devices that is showed on the screen. And it will be having some sort of simple interface, the processor which is inbuilt, the sensors which will be sensing the parameters or else the input matrix, and then there may be some sort of actuators which will take care of the response part. Then there are certain industrial production systems. I had shown some figure over here which is taking care of the industrial production control kind of thing, and the embedded chip is inside the production system, you can see. And then another example we can see are the information systems like the wireless communication, mobile phone, wireless LAN, end-to-end user equipments like wireless routers. So all this comes under the embedded systems, that too in the information category, information system category. So before concluding this particular system, before concluding this particular session, let us recap. We had started with the definition of the embedded system. We had seen the applications and what are the devices which comes and which have these embedded systems inside their the instrument that we had seen, and then we had seen different types of components that constitutes the embedded system, and then we had seen the categories of microprocessors, and then at last we had seen the examples wherein which these embedded systems are used. With this, I'll conclude the session. Thank you. Happy learning.